problems in this video will look familiar if you recall them from last year. The main idea is to take a situation like this, and again to draw a free body diagram. So we have the weight force pulling down, which I don't know. We're trying to find the mass. So after we figure out the downward force, we'll divide by 10 to find mass. And then we also have two tension forces pulling to the sides, but not exactly the sides. They are pulling somewhat up and somewhat left and right. And so what we want to do is we want to break these diagonal forces into components. I do always suggest that you go out and then up when building these triangles. And so really what we want to do is we want to figure out this force right here, which is going to be the same as this one since it's a symmetrical situation. And when I add those together, or double one of them, that's going to tell me this downward force, and I'll be able to find the mass. So we just need an angle. Since this is 28 on the original problem, if I take 180 minus 128 and divide that by 2, it'll tell me what the angle is on both sides, again, because it's a symmetrical system, and this comes out to be 26. Now, it would actually be true that the F of x forces on both sides would also equal each other. Although that's true, though, that's not necessary in this problem. So we'll just focus on the fact that the forces in the y direction must balance out to 0. So we have two upward forces, F sub y, minus the downward force of weight equaling 0, or the two ups have to equal the down. The force F of y can be found directly, though. That's going to be the tension force of 280 times the sine of 26. And so that will equal our mass times 10. And when we go through and solve this all the way through, we'll get that our mass is 24.5. It's not the only way to solve this question, but it's a nice clean solution that uses, again, the fact that the sum of the forces is 0. All right, so this question also involves kind of a similar setup, except it's not symmetrical, at least we can't assume that it is. And so I will go ahead and draw a free body diagram that I can work from. I do know the weight force pulling down is going to be 110 newtons, since I know the mass is 11. And I know this force here is 54, and I can also figure out an angle here. Since I'm given that this angle up here is 140, I can tell that this one right next to it is going to be 40 degrees. And since I've kind of got the Z shape here, then I know that this angle down below is also 40. So I've got really all I need to find the parts of that triangle. Let's go ahead and do that right away. I'm just going to call these sides A and B so I can keep track of them. So A is going to be 54 times the cosine of 40. And let's see, that comes out to be 41.4. And then my B value, I could use the Pythagorean theorem, but I'm just going to go ahead and keep going with the pattern. 54 times the sine of 40, and that one comes out to be 34.7. All right, so let's turn over to the other side of the triangle, or this other side of the picture. So this tension force that I'm looking for is pointing at some angle from the other rope. Okay, so we'll first find an angle inside this triangle, this angle here, and then we'll use that to figure out theta in a second. But we also need to find the tension force. So using the idea that the sum of the forces in the x direction are going to have to equal 0, I can say that if this is A, then this side is also A. So I know that I know that this can be labeled then as my, what was that, 41.1. And then to figure out the other side, I know that the sum of my forces in the y direction must also equal 0. And so if that's the case, I already know that I have this value of B that's upwards, that's 34.7. And then I have this other side that I'm looking for. Let me just temporarily call it C. So those two up forces are going to have to equal the down force of 110. And so from that I can figure out here 110 minus 34.7. So that one comes out to be 75.3. All right, so now we've got this other side over here. Most of the parts of our triangle are known now, so 75.3 newtons. And so we could figure out using Pythagorean theorem that the tension force in that rope, 75.3 squared plus 41.4 squared, that gives us our tension force. There we go, which is 85.9 newtons. And then we also need to find an angle here. So again, the angle that I'm going to try to find is this angle down here. I'll use the tangent function for that. So my angle, I better not call it theta, we'll call it phi, is equal to the inverse tangent of 75.3 over 41.1. Again, that's not my final answer. That's kind of just helping me get to it. And when I plug that in my calculator using the inverse tangent, I get 61 degrees. And then I can kind of finally find that angle that I'm looking for, the theta. Theta plus 61 plus 40 is going to give me my total of 180. And so from that I can figure out that theta must be equal to, what is that, 101, 79 degrees.